This tutorial, we will look at using the Java persistence architecture with Spring Framework repositories. This is the high-level overview. We will get started with having a look at data entities. Then we will be creating and using persistence units. And finally, we'll look at mapping complex data types. So in order to map our entities to tables with Java persistence architecture annotation, we need to understand why we use the JPA, because it simplifies database operations in Java applications and it streamlines database interactions for applications. So we'll look at defining and using entity. We'll look at mapping our Java classes to database tables, and we'll look at what Maven dependencies need. So in order to master our JDBC interaction, what is a persistence unit? Which is a bridge between the application and database, and it manages the connections and configurations. Look at how to set up our JDBC connection, our JDBC driver, and our connection URL, username, and password. Then we'll look at database design and transactions. We'll look at schema design with an resource diagram to review our SQL table creation. We'll be writing SQL scripts for our database containing a movie studio, an actor, movie, and the movie-actor relationship table. We will understand how transactions work, which is a group of operations into one atomic unit, and they essentially have what is known as asset properties, which is atomicity, consistency, isolation, and durability. Then we'll look at mapping complex data types and embeddables like enums, dates, times, and large properties. Embeddables are reusable complex types with the tag of embeddables, and then collections are map lists or sets with JPA annotations. It's basically enums and temporal types. Use @enumerator to store enums in the database, and we use the storage strategy of ordinal versus string. Now we'll look at our course documentation, starting with entities, and we already went over some of this in our slides. Why use JPA for database operation? And now we'll look at how JPA simplifies our movie database projects. We're going to have classes like movie, actor, and studio, and their respective database tables. And in our movie and actor classes, we're going to handle many-to-one and many-to-many relationships. And it's going to help us automatically generate SQL queries for common operations. So let's start with our Maven dependency. We see we have the basic inclusion of the Spring Boot starter data JPA, even though it's not a Spring Boot project. And then of course our MariaDB client. Let's go over to Eclipse. We have created a new Spring JPA Maven module, and if we add our POM file, here is our MariaDB Java client, and here is our Spring Boot starter data JPA added. And now we come to somewhat of a chicken and egg problem, where we have our entity classes is studio, movie, and actor, and then we have our SQL to go and create these tables and their relationships. Let's look at that first. You see we use the testDB JDBC connection. Make sure that we are connected. So first we create the Spring JPA database. Then we create the studio with a primary key of studio ID and another index field for studio names. Then we have a year founded constraint, should be between the year 1800 and the current date. And we have the actor, which has actor ID as primary key and another index field of actor name. Then we have the movie table with the movie ID primary key. Here we start with a foreign key constraint of movie studio ID that reference the studio ID. Then we have a movie actor relationship table where we have the movie ID and the actor ID, and the movie ID references the movie ID and the actor ID references the actor ID. So now let's run through the whole script, our data source explorer in Eclipse. Execute all. And here we're gonna revisit getting started with entities. Previously we looked at our Maven dependency, and now we'll look at the entities, which are simple Java classes that is mapped to the database table at entity at table, and JPA automatically maps class fields to database columns by default, and you can use the column to customize the mapping. Surrogate keys or unique keys are generated independently of the data. It's also managed by JPA through @ID and @generated value. So here we have the simple actor ID example. Then you can also have composite IDs. And here we have the movie actor ID that contains a movie and an actor ID column. Then we look at basic data types. We have local date, big decimal, and a lot of other basic data types. Finally, we can also specify the column names using @columns and set constraints like nullable length. Here we did nullable false. And now back to Eclipse, and we see we've created a database, and as present there are no movies or actors or studios in our MariaDB database. So let's look at our entities. So we'll look in detail at the actor. We have a generated value, an actor ID column. It's not nullable and it is unique. And we have actor name with a length of 100. We have actor birth date of local date. We have actor nationality, which is a string. Then we have a many-to-many relationship with a list of movies. Then we have our standard constructors and getter and setters. We also have a toString to help debugging. And if we look at movie, essentially more of the same. And we have studio. It's also more of the same. Now let's go back to our course documentation, and we look at mapping entities to tables with JPA annotations. We've just started with getting started with entities. We were looking at creating and using a persistent unit. Persistent scope refers to the life cycle and context in which JPA entities are managed by the persistent context, a part of the entity manager in JPA. Understanding the persistent scope is key to managing entity states, database operations, and relations in our movie, actor, and studio entity. The persistence context is a container that holds and manages entities in memory while interacting with the database. It ensures that each entity instance corresponds to one unique row in the database during its life cycle. The scope of persistence determines how long an entity instance remains associated with the persistence context and how it is managed. It is typically tied to the entity manager or a transaction. Now we look at the types of persistence scopes. We have a transaction scope. So here the context is active only during a single transaction, and after the transaction ends on a commit or a rollback, the persistence context is cleared and entities are detached. So we have a little code example here where we create the entity manager and we start a transaction. We create a movie, we persist a movie, we commit the transaction, and at that stage the context ends and we close the entity manager. After commit, the movie entity becomes detached, meaning changes to it will no longer be automatically synchronized with the database. Then we have extended scope, where the persistence context spans multiple transactions. This is useful in stateful applications such as web apps with long user sessions. And here is how we define that with notation. So now we look at the persistence context states. Entities in JPA can be in one of the following states within the persistence scope. First, transients. In other words, it's not yet picked up by the persistence context. So here we have just created a studio and started to update it, but it's not linked to the database, so it's sort of loose. Then there's persistence, entities that are managed by the persistence context. So here everything is tracked with the database. So once we do a entity manager persist, now it's linked to the database. And then we have detach. These were once managed but are no longer associated with the persistence context. Modifications to detach entities must explicitly be merged to synchronize with the database. So after we've closed it, now it's detached, and now we have to reattach it with merging. And then also, if we remove it from the entity, we kind of mark it for deletion in the database. So now we look at the application and the relationships. So we have studio movie, one to many. In the studio is persistent, all associated movie entities in the movie list are also persistent due to cascade type of all. The persistence scopes ensures all movie entities remain consistent within the transaction. So here is our example where a studio is created and a movie attached to the studio, and we persist it. Then we look at the movie actor, which is many to many. Then adding an actor to a movie, ensure both entities are within the same persistent context to manage the movie actor relationship table. We create a new actor, update it, we create a new movie. Now we have to add the actor movie, and we have to add the movie to the actor, and only then everything will be persisted in the movie actor join table. Then we look at entity attachment after the transactions. Changes made to it won't affect the database until merge. So nothing will be up until we do a merge. So here are some best practices. First, use transaction scope for stateless applications. Then use minimize detach state. Try and avoid doing that merge after the fact. Leveraging cascading. Use cascade type all so that the persistence is simplified. And then use lazy fetching to get only what you need. So the key takeaway is the persistence scopes determines how long entities like movie, actor, and studio are managed by JPA, and understanding the states is essential for effectively managing database interaction in our movie database application. Now back to Eclipse, and when we look inside our entities package, we have created a JPA test driver to look at the entity manager. So we have an entity manager factory. We create the configuration from our Spring config class, which is here. Then we create the Entity Manager Factory using the Entity Manager Factory class. And we do create entities, read entities, update entity, and delete entity. So let's just look at the create entity. We get the entity manager. We start a transaction. We create a studio. Then we create an actor. And then we create 2 movies. And we add the actor to these 2 movies. And then we add movies to the actor, and then we use the entity manager to first persist our studio, then our actor, then movie 1 and movie 2. Then we commit our transaction and we close our entity manager. I'll leave the rest for self-study. Look at all the others and also play around, create your own little database. So let's run it. We run it as a Java application, and we look at our logs, see Hibernate insert, movies inserted successfully, reading movies, getting the movies back, reading actor, getting the actor back, and updating and removing the actor. Now let's look at the database again. So we connected to the Spring JPA database. Execute selected text, and we've run the 3 select statements. We look at studio, we have 1 studio. We looked at actor, we have 1 actor. And we look at movie, and we have 2 movies. And this is what populated our database. And now back to our documentation, and we will look at persistence in Tomcat 9 servlets. When using servlets in Tomcat 9 with Java 11, the persistence context must be carefully managed because servlets operate in a stateless and request-response model. You will need to integrate JPA into your web application and ensure proper handling of persistence scope during each request and transaction. So we look at a step-by-step approach for setting up the JPA in a Tomcat servlet-based application. We have our entities, movie, actor, and studio. Then we create a persistent unit in our XML configuration file underneath source main resources, and as you can see, this is where you set up your JDBC driver and your Hibernate dialect. Then you need to add the following Maven dependencies related to that in your Maven POM. And when you create your servlet, you use the entity manager. So you create the factory. Here we set up a query of all the movies. We set the content response type as JSON, and we output all the movies in a for loop. And we have transaction management. If we need transactions, we begin the transaction. Here we set our movie, we persist it, and we close it. On an exception, we roll back, otherwise we commit and close. Here is how we handle persistent scope. We create a transient state for the servlet, persist, set the transaction boundary, and then the detached state after the entity manager is closed. So when we configure for deployment, we do a Maven clean package. We have advanced considerations of concurrency, error handling, and performance. Now let's go to Eclipse, and we have a look at our movie servlet. Extend the HTTP servlet. In the initialize, we create the entity manager factory. Then in do-get, we create the entity manager. We set our response types and encoding. Then we run a query that gets all the movies into a result list. We set up an object mapper and register the Java time module. And then we write the JSON response as a string from the movie list. And we write it out to our JSP page. And if we navigate away from our JSP page, there is the destroy page that closes our entity manager factory. When we look at our web.xml, we see we've added the movie servlet and the servlet mapping. And then also remember we have a persistence XML. And if we look at the source, here is our JDBC connection. And here is our specified Hibernate dialect. Now let's run it on Tomcat. So we see here we don't have a landing page, but we still enabled our movies servlet. And here we have the output of our servlet. So once again, for self-study, play around, create your own landing page, update, insert, delete, create new ways of interacting with the database. Now to close off, let's look at mapping complex data types. Relational databases don't natively support complex data types. And now we will learn how to use @embeddable for reusable components and how to map collections to tables. Embedables are reusable non-entity types annotated with @embeddable, and collections use @element collections for list and set. So here is an example of an embeddable address used inside the studio entity. And here is some homework. And we look at using enums and entity types. Enums simplify managing finite values like ratings or statuses. We can store it ordinal and string. So we have @enumerated to map enums to database columns. And we prefer enum string for readability and future proofing. So here is an enum of the movie ratings. And here we've included the enum rating inside the movie class. Here is some more homework for you. Test saving and removing it. And also compare the two. Now we also look at dates and time. So the more modern standard is Java Time that came out with Java 8 and JPA supports it. Use temporal for legacy date or calendar types. That's if you're dealing with an old code base older than Java 8. If you have Java 11 or above, it's these. So here is the temporal type mapped to the old date. Here is the new local date type. Here is some more homework. Here is a homework quiz. Then we have what is known as clubs and blobs, which are usually huge image files, movie descriptions or posters. For that we have the @blob annotation. So club is large text and a blob is for images and files. Blob could be one enormous XML file for movies. So here we have the club. So here we have the lob. And here we have the blob. So here is the homework. Add the club and poster field is saving. Now if you can pair up with somebody, do a code review, do a performance discussion. In this lesson, we explored advanced JPA techniques, including mapping complex types, enums, date types, and large objects. By applying these concepts, you now do all of the following. And that concludes this tutorial. I will see you in the next one.